Flack math! Give me some math and I'll give you some flack. Flack math!
Here we go, number one. A band of gold surrounds the edge of a circular crown that has a radius of 5 inches. Find the length of the band of gold to the nearest tenth of an inch. Use 3.14 for pi.
I'm listening, even though
Okay.
this one. So basically, it's you're gonna take the diameter, which is gonna be 10, and then multiply it by pi,
Nice.
which is pretty easy because it's 10, so it's 3.14. So we have the decimal 31.4.
Wait, is this number one?
Yeah.
Yes. Or do you like this also?
Yeah, it's good. I like
Very
it.
good.
Sure.
So make sure, and this is just a grammatical thing, don't put an equal sign. Put like an approximation sign. Why?
Oh, because it's 3.14. It's
Yeah,
just a
because
rounding.
3.14 is not pi. It's just an estimation of pi. So
Well, you like how
the
much
circumference
you
is approximately 31.4 inches.
You say that, but it does say use 3.14.
Oh, and this is the wrong. Oh, this is the right answer. I was going to say 3.14. So find the length of the band. Use 3.144. Yeah. So I guess an equal sign would make sense.
Wait, is that the answer right
Yeah.
there? The C?
Oh, it's so good.
Wait, it is?
Yeah.
Yep.
Oh, okay,
31.4 because all you're doing is finding the diameter, which if the radius is 5, you just double it. Multiply by 3.14. So when you multiply by 10, you just move the decimal over one place. Done and done.
Good job. Thank you.
Number dos.
And I should probably eat
Find a
spaghetti.
line that is parallel to this. Okay, parallel to
I'm hungry.
y equals x plus 3. So basically, we don't care about, the only thing we care about is this thing right there, right? Because parallel lines have the same
Slope.
slope. So what's the slope?
Same.
What's the slope we're looking for? What is the slope of this line?
3. I don't know.
That's the y-intercept.
It's 1.
It's 1. So if you don't see a number there, it's 1. And slope is like, we like to see it as a rise over run, so write it as a fraction. So our new line has to be parallel to this. So our new line is y equals 1x. And now we have to figure out what that is. Okay? It's not going to be 3 because if it's parallel to it, it's not going to be on top of it. So it's not going to be 3. Now, how do we figure out what that number is? We need more information, right?
It gives us the point.
Well, it gives us a point that it's going through.
And then we know the point, we know the rise of a run, so we get to see the line.
So you could graph it. Yeah, you could graph it. It goes through 1, 2, which is right there. And if it's a slope of 1, it's going to go up 1 over 1, up 1, right 1, or it's going to go down 1, left 1, same thing. And then look, there's the y-axis intercept. So it's going to be 1. So you could graph it. The other way to do it is after you have your slope, then you can plug in the values and solve for b. So basically we've got this so far. So now we need to figure out what this is. So we can plug in 1, 2, plug in 1, 2. So 1 for x, 2 for y. So you get 2 equals 1 plus b. So what's b?
1.
b equals 1. All right, so now I've got all the components for my slope. I got my slope and my intercept. So there's your answer. There's a third way to do this, and that's using the point slope formula. You guys remember the point slope formula?
Isn't it x1 was like x2
That's the
over
slope.
y1?
That's you're thinking
That's
of
the final
a
run.
version of the slope formula.
Okay.
Point slope formula, if you're given a point and you're given the slope,
Isn't it the averages?
Then you
of
plug it in.
y?
nope. That's the midpoint formula. So the point slope formula is, I don't want to confuse you. If we haven't talked about it, then I won't go over it. But if you're given the point and you're given the slope, you put it into this equation, and then you just simplify the equation, and it gives you the slope intercept formula. Okay, but I don't want to confuse you with it. So you can try graphing it. So remember, it's parallel to y equals x plus 3. It's not y equals x plus 3. Okay, don't plug the x and y value into that equation. Okay. You just use that first equation to tell you what the slope is. Because if it's parallel to it, it has the same slope. What if it was perpendicular to that equation?
You flip the x.
Yeah, you flip the coefficient of x and you negate it. So it'd be -1. All right, moving on. State the converse of this statement. I love converses. All you do is switch the if and the then, right?
Yeah.
So if it is equilateral, then a quad is a square. Is that true? Is that true?
If an equilateral.
If a quad is equilateral, then it's a square. What's equilateral mean?
Oh, couldn't it also be like one of those things where it's not a square, but it's like angled?
Yeah.
So it's
yeah.
not true. So converse
Not always true.
is
So
not
there's a
true.
rhombus. So the converse is not true. Is the original statement true?
What's it?
If it's a square, then it's equilateral.
Yeah, that's
Yeah,
true.
because a square is equilateral
So,
and equal angular. Right?
Original true, converse false.
Yep. Yep. So you can say T comma F. Does that make sense? All right. Good. Okay. Remember, just one counterexample blows this out of the water. You just have to find one counterexample that is not true.
And we don't have to write our counterexample.
Nope.
do we?
Nope.
Okay.
Unless it asks for it. Okay, find the perimeter of this composite figure. So you don't care about any lines drawn inside the figure. Okay, why are you being poopy? Why?
Here.
All right. Find the perimeter of this. You don't care about that dotted line. Perimeter is outside, so just add them up. Probably the easiest question on the test. 4 plus 3 plus 3 plus 3 plus 5. What's that?
That is 9 and then 9
Plus
again, and that's
18.
All right, boom.
That's
Any
awesome.
questions?
so smart.
You're welcome
Smart.
on
I'm
that
so
one.
proud of you. You're doing so good, and
Thanks, you are too. You're
You're
doing awesome and good jobs
you're
and
doing
exclamation points.
amazing. And
You're
like,
doing amazing.
you're doing
I'm so proud of you.
So
We're just like a
proud.
proud aunt.
Oh my gosh, I would love to.
Are we done with all the gushiness?
It's so good.
Oh, she showed me that you said good job on her.
No, that was the other Flack.
Oh, well, both physics is hard.
Physics is hard.
I'm so proud of you.
Thank you. I'm so proud of you.
Here.
Okay,
My phone's going
if you
off.
don't try this, you get a 0 on this question. If you try it, you'll get some credit. What's the easiest part of a proof?
What's given?
What's
The
given?
is-
Given that C is a midpoint of it. So I'm going to write C is midpoint of AE and AB is parallel to DE. Given. there's 2 points of the proof that you already have. Good job. And what's the next easiest part of the proof?
The solution.
Yeah,
The
what
last
you're
step.
trying to prove is the last step. We don't know what number that is yet, so we're just going to say prove that triangle BAC is congruent to triangle DEC. Okay? And we don't know the reason for that, but we do know the statement. The last statement is always what you're trying to prove. Okay? You don't want to do anything after that because you've already proved what you want to prove. All right? So now when I see prove that two triangles are congruent, I start to see all these 3-letter combinations. What are those 3 letters?
S's and A's.
S's and A's, right? So I'm trying to find, okay, I know that SAS, ASA, SSS, AAS. The only thing that doesn't work is the ASS, right? So every other combination of A's and S's works, except
Oh, wait.
AAA. AAA doesn't work, okay? So let's see which ones could work. I'm just looking up here. And first of all, I'm not given that any angles or any sides are congruent. The only thing that I'm given
Is C is the midpoint, right?
is that C is the midpoint of which one?
Of
AE. So that means, what does it mean to be a midpoint of a line segment?
It's half, so they're both congruent.
So that's the definition of midpoint is AC equals CE, or AC is congruent to CE. So I'm going to write that. Step 2, and the order doesn't really matter from here. You're trying to find S's and A's, right? So it doesn't matter what order you do it in. So I'm going to say AC is congruent to EC. Why?
Definition of midpoint.
Because that's what a midpoint does. It cuts it into two congruent line segments. Okay? All right, so now we got a side. What else are we looking for? We need angles and sides. Somebody else besides Tobin. So the only thing we're given is that some lines are parallel. Well, you remember what that opens up? Parallel lines? Whenever you're dealing with parallel lines, side, you don't know anything about sides, but it does talk about angles. Somebody? If parallel lines are cut by a transversal, then they're, and then there's like 3 types of things that are congruent. You guys remember those? Should we give Tori a free problem set if she can get this?
Yes.
Where is she?
I think she had to go downstairs after she was done with her spaghetti, or she's in the bathroom.
Okay.
Yeah.
It's a 3-word thing.
I know what it is. Can I answer?
I know you know,
No, you
dude.
can't.
So I don't want you to
Can
answer.
I wait?
Wait, did you say a 3-word thing?
Yeah.
Like I'm gonna sound.
Tori!
I'm sorry.
But we need you to help, and if you get it right, you get a free problem.
Wait, what is it?
We all agreed that we're going to give you a free problem set if you can tell me
Why?
when you have parallel lines cut by a transversal, then what's congruent?
Hold up, I have to look up this. I can't see it. Give me 2 seconds.
Okay.
Is this number 5?
Number 5.
Yes.
So if you have lines that are parallel, that opens up a world of some things that are congruent.
Wait, are you talking about number
Oh, aren't the like angles congruent?
Which angles and what are they?
Alternate exterior angles.
Okay, so alternate interior angles. I'm still going to give it to you, even though I know you did. I
I'm
did.
just worried that I would get it wrong.
All right, then
Wait,
I'll
do I
give you
actually-
that. I'll give you that 5th point for your extra credit.
Wait, did I get some?
Well, you said alternate exterior, but yeah, I'll give you a free problem.
Tori, I'm so proud of you.
Okay,
I'm
So, guys,
Let me be.
alternate interior angles are congruent. So look at the parallel lines here. So these guys these parallel lines. So that means this angle D and angle B are congruent. And also angle A and angle E are congruent, right? So we have, and remember these sides are congruent. So we've got angle, angle, side, angle, angle, side. So we can use the AAS theorem to say that these triangles are congruent. So number 3 is angle D is congruent to angle B. Also, angle A is congruent to angle E. Why? Because parallel lines implies AIA. Alternate interior angles are congruent. Okay? So it's going to be a lot like that on the test. But remember, you've got 3 points that you can add to this question without thinking. Copy down the given. The reason for the given is given. And copy down the last statement. And what's now the reason for this? Why can I say these triangles are congruent?
We have 2 angles, right?
We have 2 angles on the sides. What'd you say?
Vertical lines.
Somebody said it. AAS. Angle, angle.
Yeah, I saw.
Same. You can also use vertical angles are congruent, guys. Look at this. You could have said that these 2 angles are congruent because all vertical angles are congruent. And then you could have said ASA. So there's more than one way to prove this proof. Okay? All right, moving on to number 6.
I love the choir room. It brings me so much joy.
I miss taking like music classes. I used to take them all the time and I miss it.
All right, number 6, find the distance between the point, blah, blah, and the line. So if I were to just graph this, just to get a visual, 1, 2, 3, 4, 5, 2, 3. Here's the point, and the line x equals 7 is right here. This is where that line is. Remember, x equals something is a vertical line. So now I can just say, all right, well, what's the distance? How far is that point away? It's just 2 units.
Can't you
It's the
just
perpendicular.
do-
It's the perpendicular distance. So look at the x equals 7. Look at the x value, 5. How far is 5 from 7? 2 units. 2 units. That's it. That's it for number 6. Can you guys handle that?
Yeah, that was so challenging.
So if it was the line y equals 7, if it was the line y equals 7, how far would that point be from the line?
It would be 5?
Nope,
Wait, no, sorry. 4.
right? Because y, if y is at 3, to get up to y equals 7 is 4 more units. Okay? So they might throw that on you. They might say y equals something instead of x
Can
equals
I
something.
answer? Can I say the answer for 7? Is it x equals 9 and y equals what? 5?
Let's see here. X does equal 9 and y should equal 5. Yep. How'd you get that?
Oh, it's just so basically you
They're
see
similar.
like 12 and 4 because they're similar. So you just divide 12 by 4. What do you
Yeah.
get? 3. So then you multiply 3 times 9 is 3
So
times
this-
3 is 9.
yeah.
And then
So this is nice because there's an actual scale factor. Like that first shape is literally 3 times as big
Mhm.
as the smaller shape because that top left side is 4.
Mhm.
On the smaller one, the top left side is 12 on the bigger one. So 4 times 3. So everything's a factor of 3, is a scale factor of 3. Okay, so that's nice. You can set up proportions. And remember, proportions work however you want. So you can say like 12 over 15 and then 4 over y if you wanted to. See how we just put those in the same position there? So then you can fish method that. 4 times 15 divided by 12 is 5. Okay, and then you can set up a proportion. Let's do. Now we have to find the x. See, x can go over 15, and 3 can go over y. which is 5. And you can fish method that. 45 divided by 5, x equals 9. Okay? So if it's not a nice, pretty scale factor like it is there, then you can always use proportions. Okay? You guys good? All right. Number 8. Consider triangle. Let's see the triangle. Write a proportion to show that AB is to DE as BC is to EF. So just plug in the numbers, right? Just plug in the numbers. AB, what's AB?
8.
8 is to, okay, what's DE?
4.
Where is DE?
It should be
4 as, what's BC?
12.
12
to 6.
is to 6. You're done.
It feels like incomplete. I'm not gonna lie.
I know,
Yeah.
this doesn't feel right.
Because this one, it's just double.
He seems
so it
much
feels
shorter
like
than the last test.
Yeah, it's kind of given, I like, sometimes they're just more complicated than others, but we picked a good one.
I'm so proud because
Yeah.
I was having a little bit of a rough week.
You are a proud woman.
I'm
today.
so proud today. I'm so proud of everyone. Everyone's doing amazing.
Good job, everyone. Let's take 5.
Like
yeah, let's take 5. Holy good.
Hours.
yeah.
Oh, I don't have time for a nap today.
It's okay. Dillard's is going to give you the excitement.
I know.
adrenaline
Sometimes
that
Dillard's
you
makes
need.
me feel better about myself. Sometimes it makes me feel more better about myself. But today, I think it's gonna make me feel better about
We're gonna
myself.
look
Okay,
so
in
cute.
triangle
I
XYZ,
agree. Oh,
I
I'm
have
ready.
heels in my car.
You do? Why?
Church.
Oh, I don't wear these. I wear these.
I just wanted to like.
okay, XYZ, XA. So I'm just gonna write XA as a median. How do you draw a median?
Oh, isn't that the in between them, right?
Okay, so XA, so where's A gonna be? Right there, right? A median is drawn from a vertex to the opposite midpoint of the opposite side.
And doesn't it?
Okay,
Yeah.
so here's XA. All right, and then M is the centroid of the triangle. So do you remember how to find the centroid of a triangle?
Yeah. Don't you do it with all of the points and
Yeah,
where they
so
are?
you could, so you do the median for all of the vertices. So that's the centroid. Now what's the relationship with the centroid?
Oh.
You guys remember the relationship?
Yeah, the top side would be 2/3.
Yep. So the longer side is 2/3 and the shorter side is 1/3. So what is the length of XM if XA measures 1? So this whole thing is, so basically we could say something like this, right? We could say, so XA, look, all right, here's M. So XM, that looks like, yeah. So XM is 2/3 of the whole thing, right? Of 163.2. Does that make sense? So make sure you draw it because you'll be able to tell which one's 2/3 and which one's 1/3. Okay? So this is always 2/3 and that's 1/3 of the whole thing. So if this is 2/3 of the whole thing, it says XA is 163.2. Then let's just do it. Let's figure out what 2/3 of, how do you do that on your calculator?
Couldn't.
Several ways.
Yeah.
So you can multiply that. So you could just double that and then divide by 3.
That's
So
what
someone
I
want to do that on their calculator?
Okay.
So 2 times 163.2 divided by 3. But
Is it 108.8 centimeters?
what'd you say?
108.8 centimeters?
108? That sounds like
Correct.
2/3. 108 point what?
That's
Sorry.
All right.
calculator agrees.
Boom. Okay. So what if you were asked to find AM?
It would
be-
1/3, so you would just divide by 3.
Yeah. So you just divide by 3. If it's just 1/3, then you just divide by 3. And we could have divided this first thing by 3 and then multiplied by 2. It doesn't matter if you multiply by 2 first or divide by 3. Okay, that's number 9. Number 10. A triangle has side lengths 15, 8, 12. Classify the triangle by side lengths and angles. Okay, so
Is that
15, 8, and
Pythagorean
12.
triplet?
So if it's a Pythagorean triplet, then we can say right away it's a right triangle.
Yeah.
Okay? But first of all, let's classify the triangle by its side lengths. What are the 3 types of triangles if you're talking about side lengths? Yes.
I'm gonna sound stupid. I thought you'd like the cute, right?
Acute triangle, those are the angles.
Oh, then
What about side lengths?
Oh, isn't no, never mind. Like
Because you sound like it's on the tip of your tongue.
Right triangle.
Those are still angles. If you're classifying a triangle by its angle, isosceles.
wait, I got that right.
Yep,
Pythagorean.
isosceles.
That's the one, right? I'm not crazy.
that's a theorem. Isosceles triangle has 2 sides of the same length,
And then the one where it's like one side and the
but
other
no
ones
sides are the same.
zero.
That's scalene. So first of all, this is scalene, right? Because
Yeah.
all 3 of the sides. So we can say scalene first, and we're half done. Half credit is achieved. Scalene. Now we have to see whether it's a right, acute, or obtuse triangle.
It's probably
Okay.
It would.
So it's not a right triangle, right? Because 15 squared does not equal 8 squared plus 12 squared. But now we have to figure out whether it's acute or obtuse. So if that angle is going to stretch farther than it should. So what's 15 squared? So how does 15 squared compare to 8 squared plus 144 squared? Or plus 12 squared?
12 squared, it's 144.
Okay, so 225 is what to 64 plus 144? What's 64 plus 144?
Oh, that's 180.
I think it's 208, yeah.
Yeah, 208. That's what.
Okay, so 225 is bigger. So what does this mean?
It's obtuse.
So if that side is bigger, that means that the opposite side is bigger, so it's going to stretch farther than the right angle. If this was equal, then it'd be a right angle, right? Then it'd be a right triangle. But if the hypotenuse is bigger, that means it's going to stretch farther. So that means if this is bigger, if c squared is bigger, then this is obtuse. Let me just make sure.
I was gonna say obtuse too.
I said obtuse. Like,
So if c squared is bigger than a squared plus b squared, then it's obtuse. If it's smaller, then it is acute. Okay? All right, moving on.
I'm so proud of you, and Dylan is confused.
and your earrings are so cute. Yours are so cute.
Actually, I got them for free because I bought them on Netflix.
All right, moving on to 11. We're halfway through.
Free, it's automatically better. I don't make the rules.
Like that one sweet tea.
A triangular scarf has an area. So a triangle has an area of 35 square inches. So I'm just going to do something like this. Area equals 35. The base of the scarf is 3x inches. And the height of the scarf is 2x plus 2. Find the base and height measurements of the scarf. Provide justification for each step. Justification for each step is extra credit, but I want you to do this. How do you find the area of a triangle?
Oh, it's length times the width. Or, no, divided by 2.
Yep, so we're going to go 3x. So we could say 1/2 3x times 2x plus 2, right? So far, so good. And what does that have to equal?
Equal equals 1, 2,
36 square inches. Okay, so 1/2 base times height. You see how I did 1/2 base times height? Okay, so let's see here. Let's just do this first, and then we'll multiply everything. Or, well, no, let's not do that first. We'll go 1/2 times 3. So this is 3/2 x times 2x plus 2.
Is that
So
so
then you get
Yeah.
3x squared
X is in the equation.
plus 3x equals 36. Okay,
Yeah.
all right. Now to make this easier, I could divide both sides by 3 and get rid of those 3. So I'm kind of reducing the equation. So I get x squared plus 3x equals 12, right? This is a quadratic equation. I am going to make this all extra credit. So the whole thing is extra credit. It's double extra credit if you can provide justification, which we'll do afterwards. So to solve a quadratic equation by factoring, you can get everything on one side. That should be an x there, sorry. Minus 12 equals 0. Then factor, cheeks and tats. So plus 4 minus 3, so x equals 3. It can't be a negative number because that would make our dimensions negative. So x can only be 3. If you don't know how to do this, that's okay. This is algebra, late algebra 1, algebra 2 concept.
Horrible.
So x equals 3, but it doesn't ask for x, it asks for the dimensions. So that means this is going to be 9. Base equals 9.
And then 6 plus 8 is 8.
And then your height is going to be 8. Okay, and y for each step, this is just area of a triangle. This is simplify distributive property if you want, but just simplify works. And then we divided by 3, so division property of equality. And then we subtracted 12 from both sides, subtraction property of equality. And then we factored, so factor, and then we solve. Okay, those are justifications. So if you want to do that for double extra credit, you can. But yeah, that's it for number 11. I'm not going to spend much time on it because it is extra credit. So let's do number 12. Give a Pythagorean triplet. Basically, you just have to reduce this triplet. So what is this reduced to? What triplet does this reduce to? Well, what are some examples of Pythagorean triplets?
Isn't it like
3, 4, 5 is 1.
12,
probably-
13,
that-
5?
12, 5, 12, 13, yep.
I wonder probably.
Let's see
That
if
looks
it's,
like a 3, 4, 5 to me.
so if you made that
100,
smallest
so
number a
that's
3, so
25.
divided by 33.
Yeah, and then that's 25 plus what, 8, which is 32.
So yeah, so if you take,
60.
so if you divide them all by 33,
12, 20, and then 5. 12 plus 20.
what is that,
It's 12
165?
plus 20 plus 5.
So this is 3. Does 33 go in there? Should, right? 4 times. And 33 goes in there 5 times. So it's a derivative, or it's an equivalent Pythagorean triple of 3, 4, 5. Okay, so you need to know this one. Don't forget 5, 12, 13 is another one. So you just have, this is your answer.
3, 4, 5.
Yep. And even if you just reduced it a little bit, technically,
That's
give a
what I
Pythagorean
think.
triple that is proportional to that. You could say, well, 33, if you divide everything by like 3,
It's 30.
I mean, it's just, but this is the simplest triplet, okay? All right, number 13, use LA congruence theorem to prove that triangle ABC and DEF are congruent, okay? So it's technically approved, but they just give you what to say. So LA, so you could say since the leg, since leg BC is congruent to leg DE and LA, so angle F is congruent to angle C, then triangle ABC is congruent to triangle DEF by LA. Okay, so you just have to state that the L's are congruent, the legs are congruent, and then state that the A's are congruent, the angles are congruent, and then say, since we just said that out loud on paper, then we can say that those triangles are congruent. Okay, so this is an easy problem. You just have to reiterate what you're already seeing. Okay. All right, number 14. Supermarket chain has 3 stores located throughout the city at points A. So we can graph these. 3, 2, 1, 2, 3, up 2. 7, 2. 6, 7. Okay, and 7, 6. Okay, so here's like a little triangle. So far, so good? So that's A, B, C. The supermarket warehouse is equidistant from the 3 stores. Find the location of the warehouse.
Wait,
How do you find this?
wouldn't it have to be the
Well, let's see. Let's see if that's the centroid. So if I drew the centroid, it would be right there, blip, blip. Centroid to there, it's right there. Centroid to there is about right there. So yeah. So that is going to be yep, centroid. Okay. So find the centroid by drawing the median to each vertex. So go from the vertex to the midpoint of the opposite side. And you can easily, if you use graph paper, guys, this is an easy problem. Use graph paper and a ruler and plot each point and then draw the centroid to the midpoint. You can calculate the midpoint of each side easily. Just halfway between the X's and halfway between the Y's, okay? And then it's gonna go right there. And so let's see, that is 1, 2, 3, 4, 5, comma, 1, 2, 3. So that warehouse is located at 5, 3. It could be 5, 4, but I don't have graph paper, so I don't know for sure. Okay. Find the location of the warehouse. So 5, 3. Okay. Can you guys handle that?
Yes.
Okay. Number 15. All right, so we're just naming stuff. Tangent line, remember, is the one outside of the circle that only touches the circle once. So that's AC. So tangent is AC. Okay, these are just definitions that you need to remember. A tangent is that line drawn outside of the circle that touches the circle only at one spot. And identify the point of tangency. So the point of tangency is where it touches. B. Point of tangency is B. Okay, can you guys remember that? So you just need to be able to identify a tangent line, and the point of tangency is where it touches the circle, at B. Okay. So it got a little tougher, but we got ones that are kind of nice. All right, 16, I think we went over this. This was an investigation, so investigations are always extra credit. So you can do this if you want. What is the sum of interior angles measures of a convex irregular pentagon? So that's always basically n minus 2 times 180. So it's a pentagon, so it'd be 3 times 180. So if you want to write this down, that's always the sum of interior angles is the number of sides minus 2 times 180. Okay, think about a triangle. What are the sum of the angles in a triangle? 3 minus 2, which is 1 times 180 is 180. So a quadrilateral, 4 minus 2 is 2. 2 times 180 is 360. So in a quadrilateral, the sum of the interior angles is 360. Sum of the interior angles in a pentagon, you just keep adding 180 every time. Okay? That's, I'm still going to make it extra credit though, so do that. So irregular, it doesn't matter if it's irregular or regular, it's always going to add up the same. Yeah, I don't know if it'll ask for exterior, but if it does, that's, you just need to look at investigation 3. Okay, in the parallelogram shown, what are the measures of TQR, QRS, and SRU? So use your gut here. What do you think's going to happen? Either angles are going to be congruent or they're going to be supplementary in a parallelogram, right? So what angles are 81 degrees? What other angles are 81 degrees? You can say top left, top right, bottom right.
Right?
Top right, but the inside, yeah. So 81.
Opposite interior angle.
So this is going to be, it doesn't even say, you don't have to justify it.
Yeah, I know. I'm just wondering
But
if that's why.
You can't, that's not why. It's because that's not cut by a transversal. So, so you would, it's because of properties of parallelogram, opposite angles are congruent. So 81, so if these are 81, what are these angles?
They have to be equal and have to add up to
Yep.
360.
Not three, well, they all have to be add up 360, but they're going to be congruent. So these just have to add up to 180. And they look like they would, right? If I put this angle on this side, it would be the same angle. Okay? So this one is going to, these are actually, you could use the not corresponding angles, but the same side interior angles. So this is, what is that? 99. So that's 99 degrees. That means this is 99 degrees. Okay? So that's all the angles. You can figure out which goes with which. TQR is that top left. QRS is the top right. And SRU is that top right outside, which is 99. Okay? Feel good about that?
Yeah.
Again, use your gut there. It's pretty easy. Number 18, order the lengths of triangle order the lengths of sides. It didn't put sides there, least to greatest. Okay, first of all, what's that third angle?
It looks like it's congruent to
It looks like it's
Y.
congruent, but I don't think it is. How do you figure out that third angle?
You just 180.
So 180 minus, what is that? 120? So 180 minus 120 is 60 degrees. Okay, so which side's going to be the longest? And which side's going to be the shortest?
Y is longest, X is shortest.
So those are points, not sides.
Oh, well.
So yeah, so Y is the side opposite of Y is going to be the longest, right? Because it opens up the farthest. So that means XZ is the shortest or the biggest. So I need to do that last. What's the shortest side?
That would be
X.
XY. No, YZ.
YZ, it's across from the shortest angle, YZ, and then XZ, and then XZ is the biggest,
And then YX.
so XY is the next one. Does that make sense?
Yeah.
Okay, use your gut. I mean, they're not going to draw it incorrectly. So the only one that's the one that's obvious is YZ is the shortest, right? You can see up there. And the only way to know for sure if whatever one's the biggest, figure out the angle of Z. You can do that by just using the 180 rule. All right, 19. What is the included side of PQ and PQR? So let's draw just a random triangle, PQR. The included side of angles QRP, that one, and PQR, this one. So what's the included side of those two angles?
It's like RPQ.
So a side is 2 points.
Oh,
So it would be QR.
QR, it's the one in between. This is the included side, because in other word for included is the thing in between.
I got it mixed up with, because I was like, oh, P, but it's the line.
Okay, and it might ask you, it might say, okay, what's the included angle of line segment QP and RP? What's the included angle of QP and RP?
That would be
P.
Angle P, the angle in between those two sides is angle P. Good. All right. So make sure you label it correctly. So this would be line segments QR. Let me just put that up there just so you have it. So QR is the included side. All right, number 20, triangle PQR is a base of 5 units and a height of 3 units. Angle R is a right angle. Okay, position PQR on the coordinate plane. So what's the best way to put this?
So you base the height to start, so it's a base of 5 and a height of 3.
Okay, so where's the best, what would make the more sense and make it easy to do the graphical mathematics? Where should I put this triangle?
At 5 and 3.
So if you put it at 5, so 5 here,
With a base
and then
of 5 and the
height of 3. So yeah, and then put the
triangle.
that angle in the middle there. So that's the easiest way to work with that triangle. And that way, it's clearly that the base is 5 because you just count over 5. And there's actually might be a number 5 there on the graph. There might be a number 3 there on the graph. So that makes it easiest to work with on a coordinate plane. Okay? Again, use your gut there as well.
So angle R is the right angle, so it would be.
Yeah, and then you'd have to label it too. So PQR, so it doesn't matter. It doesn't say which one's the height or whatever, so you could just say PQR. So just make sure that R is the right angle.
Is that it?
Yep.
Flack math. Give me some math and I'll give you some flack. Flack math.